Normally we do monthly space news. This time we'll kind of do a really quick review of what happened in 2024 and a look ahead at what's coming up in 2025 and a little bit beyond. Obviously that mishmash of pictures up there reflects things we've talked about during the year in the past. So let's do, first of all, space by the numbers. What happened in 2024? We got a table here. Your eyes may glaze over, but the important thing is that last column for 2024 showing what countries launched how many rockets, and pretty much going by the first stage, who owned it, who made it. And so the U.S. here is the leader. What that really means is SpaceX is what it comes down to. It's mostly SpaceX.
Should we give a shout out like, yay?
Yeah. Go USA. Yeah, there we go. Okay. China's held kind of constant, but in general, they are working very hard to catch up. And they are going to start launching a whole lot of constellation satellites for communications, 2 different complete ones, the 10,000 satellite kinds of things. So they will be starting to catch up. Their problem is they have yet to master the fast tempo that the SpaceX can do of launching every couple of days. They haven't gotten to that point yet. Notice these are ranked in order by either the number of successes, which is the first number there, or the second numbers, which are the number of launch attempts. So usually they're pretty close, but everybody has a failure now and then. Even SpaceX had a couple of failures this year. So third is Russia at 17, Japan 5, India at 5 also, Iran at 4, which is ahead of Europe. I mean, that's kind of it's sort of sad how far Europe has fallen. The entire continent of Europe, is only, but some of that's kind of a fluke in that they're kind of in between generations of rockets. They had pretty much stopped production of their old ones, and they hadn't actually built their new ones yet. So there's new ones coming online this year, so that will help them quite a bit. And then the oddballs, North Korea, South Korea, Israel didn't have much of anything. What's interesting is the trends here. If you look at 2021 to 23 or 2022 to 24, basically we're doubling every 2 years. I should get down to my footnotes down there. Our count there did not include the Starship test. There's 4 of those during this year because they didn't really go orbital. This was really how many rockets achieved orbit or beyond, going to the moon or some other planet. SpaceX accounted for most of that, when you get down to it, the 133 out of the 155 launches or successes. And of course, most of that reflects communication satellite constellations. I mean, Starlink in particular, being a vast part of that.
I've got a question about your chart.
Yeah.
Should we eventually start separating your chart showing SpaceX different from U.S.?
I put that in the footnotes.
I just wondered, because a lot of the American launches are all SpaceX launches, aren't they?
Yeah. But, coming up, Blue Origin will probably finally come online this year. And there's going to be some launches from the others, Vulcan and those sort of things. And technologically, they're way behind, but nonetheless, they'll get a lot of business just because SpaceX can't do it all, or those companies don't want to give money to SpaceX. So either way.
I was thinking as they go forward, it's going to become an issue. SpaceX starts launching a lot of bigger launches, independent of the American, NASA program.
Oh, well, it is independent now. Well, most of it's for their own purposes because it's Starlink, which is communication satellites. That's for them. That's not really for the U.S. particularly. That's actually one of my trends I'll get to later. The commercial launches are what dominates now. It's not military anymore, and it's not prestige. It comes down to things like communication satellites or Earth observation satellites where you monitor what's going on all over the world. And that's really where the business is going these days. Starlink is a big part of that, but other constellations will be starting up, in particular Amazon's Kuiper project. They're going to actually have a couple token launches on SpaceX, but not much. They don't want to do that. They're basically funding all the other competitors right now. If it weren't for the Project Kuiper, they would just be dead, essentially, even though they haven't started yet. But, they've signed contracts to launch quite a few. Okay, but there's another way to measure, and that's mass to orbit. You can talk about launches, but then there's a lot of launches like the Electron rockets from Rocket Lab. They're pretty small. They don't really launch a whole lot. You start looking at the mass to orbit. SpaceX is up there at 1.5 million kilograms. The next one is China. They're down there, so like a factor of 20. Now, in the case of China, they don't really report a lot of their launches or what they're really launching. So that's why where I pulled this number from, they also indicated how much was actually reported. In this case, China only owned up to essentially 20%. But you can say that probably they launched quite a few more tons than shown here. But you still kind of get the idea that most of the mass that's going up there is, again, being done by SpaceX. SpaceX, in terms of launches, is already more than half. There's more launches from SpaceX than the rest of the world combined by number of launches. And the same is true for mass, even more so.
And so that 62,000 kilograms is that 18% reported?
Yeah, they've only reported that much, so you don't know about the rest. But it might be 5 times as much, as an example. Even if they had 5 times as much, that still only puts them at 300,000. Anyway, there's some Russians there. MHI is Mitsubishi Heavy Industries out of Japan. India is coming along. They report everything. The ISRO is the Indian Space Research Organization. Okay, other things to look at here. I decided to start keeping track of this because most of the growth in all these launches has been for low Earth orbit because of Starlink communication satellites and so on. Wikipedia reports this, so I just took their numbers. I didn't take anything before 2023 because their total launches didn't match up with anybody else's, so I just sort of gave up on that. But these are consistent with total numbers of launches that everybody pretty much agrees to. They categorize them this way, starting with transatmospheric. What that means is ones that maybe they go around the Earth once or twice, but they dip into the atmosphere so far that the friction slows it down and they don't last very long. And usually that's by accident. That happened with SpaceX. They had a second stage that didn't do what it was supposed to do, and they lost a whole batch of satellites as a result of that. Sometimes they might be tests, like if they're testing a space plane. Most of the growth, though, even in 2023 to 24, is in the low Earth orbit and sun synchronous, which is a special case of low Earth orbit, meaning, it's not up there too high, but it also has some special characteristics of it's in the same place in the sky every day, that kind of thing. The next one up is the high ones, which are the traditional ones, the geosynchronous satellites. They're the ones that typically go in an orbit around the equator or close to it, very, very high up, the 25,000 mile kind of category. Those are where, for instance, almost all the old spy satellites and communication satellites were and still are, but that's been holding steady for decades now. Those orbits, especially the ones around the equator, that's pretty much filled up at this point, even though it's way, way out there. There's variations on that. So geosynchronous means basically a big circular orbit. But a lot of times what happens is you see somebody does a launch and they're launching a satellite which is going to end up in a geosynchronous orbit, but the rocket doesn't take it that far. The rocket really takes it to an elliptical orbit that's really coming down all the way to low Earth level, and it's a transfer orbit which will also take it up, but it won't stay that way. Then they have to circularize the orbit, meaning they apply thrust, like with an ion engine. It's very, very low thrust, but they apply it for 6 months or something, and it eventually works its way up. An awful lot of the satellites get launched that way. They don't really very often go all the way up to being a geosynchronous, high-level circular orbit. Tundra is just a giant elliptical orbit used typically by the Russians. If you want to hover over an area like around the North Pole, the geosynchronous satellites can't really do that because they're based around the equator. Medium Earth orbit, there's some communication satellites there. The GPS satellites are there. And so there's been kind of a steady but not growing population of that. High Earth or lunar transfer, these are typically lunar missions. There have been a few of those. And then, of course, the ones that are going even farther. Heliocentric just means you're basically going orbit around the sun. Everything we've done so far, maybe except Voyagers. The main thing that you want to track is the growth is still in the low Earth orbit area. That's the area that's the most crowded. Okay, now in terms of qualitatively, the highlights, what sort of things happened in 2024? Well, one, we already talked about it here. SpaceX is kind of dominating everything, basically launching more than the rest of the world combined, by launches or by payload mass, either way. Of course, there's a reason for that. They deserved it because they got the costs down, because they focused on cost, which nobody else did, in particular when they went through reusability. And most of what I'm calling the competitors, like the Europeans and the Japanese, they were still targeting making something as good as the Falcon 9 was in 2010. Okay, they're that far behind. I mean, they just came out with the Vulcan, which is pretty much like that. The Mitsubishi H3 is pretty much like that. The Ariane 6, pretty much like that. All those things that everybody else was building are just already way, way behind. The giant constellations got going. That's mainly because of reusability. It just made it possible to launch a lot more often and a lot more cheaply. But the next thing, of course, is Starship. Its testing at this point has pretty much convinced everybody that it will succeed. I mean, obviously, there's a lot of things they still have to do. But all those nagging doubts that were on there earlier that, oh, they'll never be able to do reusability with a large, heavy lift vehicle or this or that, that's all pretty much fallen. Everybody's kind of given up on that. All that trash talk is pretty much over. And the other thing, though, of course, with them, we talked about this in one of the previous meetings, is their launch revenue is important, but it's not as big anymore as the satellite-based revenue, which they're getting from Starlink. Their internet service is actually now funding everything they do. And they have about 6,800 satellites up there, 6,800 some. That was as of January 8th. Those pictures there are just kind of reminders on what their businesses are. Falcon 9, because of the reusability, frequently lands on an ocean-based platform, or it might return all the way to the launch site. Starship testing, they're catching with these mechanical chopstick arms. That's a picture of the booster coming back. On the right-hand side is a reminder of the satellite business essentially filling the sky. Now, in reality, the sky is not filled up as much as it looks like there. That's just phase one with 1,500 satellites, but no satellite there would be as big as 1 pixel. You look at this and you think, oh my gosh, there's no room left. There's still a lot of room left up there. Okay, more space highlights. The big theme here is commercial activity is increasing in a lot of ways. And this even is affecting the military. I mean, it showed up, for instance, in the Ukraine war, where right away the people in Ukraine started realizing, oh, they can use Starlink for their own purposes, for communications and for navigation and everything else. In the old days, the military, for instance, the spy satellites, there were big ones, they were up in geosynchronous orbit, they were over $1 billion a satellite, often a lot more than that even, up there way high. And they suddenly realized now that those things are just big, juicy targets. It's too risky to put all your money in just a couple of giant satellites. And so now already, the US, they have a constellation of about 100 low Earth orbit satellites doing a lot of the same stuff for monitoring. And that's for monitoring what's going on with people's militaries, monitoring for nuclear explosion, takeoff of rockets that might be ballistic missiles, that kind of stuff. So Starlink, of course, is the big private satellite constellation, but there's a whole bunch of others coming along, including China's and Amazon's. Now, what's new is that private companies are now landing on the moon. Of course, companies always built these things under government contracts, but what's different is now the governments are just buying the service. They are now a trucking service. You're buying the service to get you in a big truck to get to the moon. And so at least there have been 2 soft landings in the case of Intuitive Machines and iSpace. That's a Japanese company. I'll get to those in a minute later. We also had the first commercial spacewalk. That's the one picture on the bottom left over there. The space station plans that are being done for commercial space stations, they're firming up. Vast says they're going to launch their first small one in 2025. That one kind of surprised me. I hadn't realized they were that far along. They always talked about having artificial gravity in their stations, but that'll just be a single module. It'll be something that later on will fit together in a bigger station, but they're getting something up there. There's another one, Axiom. They're looking at putting up something. It won't be up that early, maybe 2028. And the other thing that was really getting obvious this year is space manufacturing is starting to look like it might actually happen. Varda in particular, we talked about earlier in the year, the upper right-hand picture there, that little satellite there, inside of that, they have a miniature factory. They were making drugs, very high-value drugs. It turns out in microgravity, they can make much better quality ones. And there's similar things going on with fiber optic cable from Flawless Photonics. Redwire is doing a bunch of stuff with pharmaceuticals also. Airbus was doing some stuff with metal 3D printing in space. So a lot of this stuff is coming along. It's starting to look like it'll really happen. Okay, next thing on highlights is lunar landings. Again, this has really picked up. We really are going back to the moon, hopefully to stay. It remains to be seen. Now, some of that's China. I mean, China has really come through strongly here. They've actually returned samples from the far side of the moon. I mean, this is something the US has never done. They're way ahead of us on that. We know how to do it on Mars, but we've never actually done it somewhere as close as the moon. They put up some lunar communication satellites, communications relay satellites to do that. If you're going to have something on the far side of the moon, you can't talk to it because the moon blocks it. So you have to have a satellite up there to pass it on. And we had the 2 soft landings. Japan's Slim lander and Intuitive Machines had Odysseus. Now, the only bad part was they landed and they tipped. You can see the bottom pictures there. The only ones that actually landed upright was a Chinese one on the far side. And previous times they had done it on their side as well. That's the Japanese one there in the middle on the bottom. It landed and it kind of rolled, but they still got some things done. So they called it it was at least a partial success, not a complete one. And the Intuitive Machines one, the same kind of thing happened. It landed, but it tipped.
Did India have a lander?
They did. That was the previous year, 2023. Yeah, they've been doing this too. And India is becoming a major space power.
And they even announced their first set of astronauts.
Yeah. That's actually one thing I didn't get into the slide. I probably really should have. Okay. Now, in terms of deep space kind of stuff, there were 2 big ones, and you're going to hear more about the NASA Clipper one a little bit later in today. But NASA's launched the Europa Clipper. Europa is a moon of Jupiter, and there's a lot of interesting reasons why you want to do that. And the other one is the European Space Agency did launch the Hera mission, launched on a Falcon 9. That's the follow-up. NASA had done this DART mission to see if we could blast our way into an asteroid, we could change its position. So if it were coming in and we're going to crash into Earth, we might be able to divert it. A test of can we even do that kind of thing. And so we did that, and it looked like it was pretty successful, but they're sending a follow-up mission to go back and take a good look and figure out what really happens. The problem is it's far enough away that you can't really see it very well. I mean, even with things like the Hubble telescope, you can't really make it out that well. So those are major highlights in terms of deep space kind of missions. Okay, some things that are coming up. So this is 2025 now and beyond. One big one coming up is Starship. Despite everything I said about the Falcon 9 already is kind of dominating space, this is really appears to be the real future of space. I mean, this is a factor of 10 or more cheaper to get stuff to orbit. I mean, it's that much of a difference. So this is the single most important rocket program going on right now. And that's test number 7. They're still doing only suborbital tests for a variety of reasons, one of which is they don't need to do any more than that. They're still trying to prove out launching, returning back to the launch site, that sort of thing. They're still using the Raptor 2 engines. They have Raptor 3s coming along, and they've built them. They're much, much more efficient, so much, much more powerful and efficient, and that'll increase the capacity of this thing even more. They're not using those yet. What they're doing in this test, the Super Heavy booster, first of all, they're coming back to the launch site like they did in Test 5. That's their plan. One thing they're doing that's different is they are reusing one Raptor engine. They haven't done that before. Their whole goal is to make the whole thing reusable. Well, okay, well, let's at least do the engine, starting with one. And obviously, during the year, they'll do a lot more. Yeah.
The first time I heard that they wanted to return the booster to the pad, I thought the kids were
Everybody thought they were crazy. Actually, there were people in SpaceX that thought that was crazy. When Musk pushed it, and it turned out he was right. Yeah.
Double pilot.
Yeah.
Think outside the box, but indeed a mile away.
Yeah.
The box.
Yeah. And I'll say some of that is also a tribute to the fact that the people that do the controls to do this stuff are just really good at their job. And they have the best, they obviously have the best in the world right there. So the tower also had some changes. In particular, in Test 6, they ended up not bringing the booster all the way back to the landing site. They had some problems and it got flagged. Some of those problems apparently were related to sensors on the tower that weren't working. Now, that includes radar, which they've now upgraded. I don't know what else they were sensing, but the radar mainly was used to figure out the position. They want to know within about a half a centimeter where that booster is. And this is a giant booster coming in, still pretty fast, pretty heavy. They need pretty precise landing, and they're doing whatever they can to make sure that works well. But as far as the upper stage, that's where a lot of the real interesting stuff is happening right now. The upper stage, which is what they call SHIP or Starship, it's actually a whole new version. It's called Block 2. The aerospace industry, they make up these words Block 2. You see that kind of thing all the time. Anyway, version 2 is all that means. And they are testing out a new one. For one thing, it's taller. It's 6 feet higher, so they've added more fuel tank capacity. Most of that went to that. They also actually took a little bit of the payload volume out. There are some changes. The flap design, the forward flaps, they're the things that allow it to coast down and do it under control so they can stay at a particular orientation, in particular keeping the bottom facing the Earth, because that's the part that heats up. They don't want to flip it over. There's no tiles on the tops. They need to do that pretty carefully. New avionics, thermal protection, that's still the biggest issue. It's suggested in this picture on the bottom here. That's sort of what it looks like when the stage 2 is coming down to Earth. It's relying on getting very, very hot, and that slows it down. But obviously, if it burns through, then you lose it, you can't reuse it. So they have to worry about that. They've also done some stuff that wasn't really clear at first why they're doing it, and they haven't really said much about it, but they have propellant lines inside the spacecraft, and they're vacuum jacking in them, meaning they're putting those lines inside of a second pipe. You could probably think of it as being kind of like a Dewar flask, a vacuum flask, basically. That is better insulation. I suppose it also actually helps if there's ever a leak, it'll catch that. One thing they're doing here is lighting up an engine in space. They did it in Flight Test 6, but they need to keep doing it. That's a fairly important one. One reason is that once you're up in orbit, you want to be able to say, okay, it's time to come out of orbit. You got to be able to restart your engines to slow down to come out of orbit. The second thing is, ultimately, a variation of Starship will be used for landing on the moon. And you want to make sure you can start your engines up again. When you're sitting there on the moon, very cold, you don't want to say, oh, darn, I can't get this thing started. One thing they're doing that's new is they're finally going to do some payload deployment tests. They haven't done that before. So they're going to simulate having 10 of their newer generation Starlink satellites. They can't launch these yet. They have the V2 Mini, is which they're launching now. But they really want to launch these ones that are much bigger and heavier. They can't do it on a Falcon 9. This is actually extremely important for them because they want to get going with getting their bigger satellites up there so they can get more capacity on their network. And then there's a variety of things they're doing. In the first stage, They have these little pins that come out so that when the booster drops down, it gets caught in those chopstick arms. Well, they don't have those on the upper stage yet because they're afraid they'll burn off because all that extra heat you're getting. You're coming in a whole lot faster from higher in the atmosphere. And so the temperatures get much, much higher on the upper stage. They're trying to put some in now just to see what will happen. They're saying it's non-structural, meaning you couldn't actually land with them. It wouldn't support the weight. But at least they want to find out, will they melt off or not? So they need to experiment with that. And this is why they're not catching the second stage yet, because it comes in so much hotter that things like little pins sticking out aren't an easy thing to keep in place. They're also on purpose going to have a steeper reentry profile. They want to basically really stress this thing to make sure that they can control it, even under very adverse circumstances. So they're actually purposely going to make this thing get as stressed as possible. Okay, other launches coming along. Blue Origin. This has been on my chart of upcoming launches now for quite a while. Now I think is really just weather. They actually want to land their booster on a barge out in the ocean, and the weather was pretty bad out in the ocean. So they put it off, but it's coming very, very soon here, possibly tomorrow. They said this landing their booster on a barge is a bit of a stretch goal. They don't know if they really can do it, but they're going to give it a try. They are going ahead and putting a big payload simulator in there, 45,000 pounds. That's pretty substantial. Even the Starship earlier test, they didn't really have much of a payload at all. I think because the engines were still pretty new, they weren't really sure they were getting enough power out of them. They weren't taking any chances. I guess Blue Origin is now confident enough in their engines that they're willing to actually do that. Now, they're not going to launch that payload. It's just going to be stuck on the upper stage. We talked about the Starship flight test. There's a whole bunch of lunar landers coming along this coming week. There's two of them, one from Firefly and one from iSpace Japan. They're actually going up on the same Falcon 9 rocket. You might say they're competitive, but they're both going up on the same rocket. And that'll probably be January 15th. Now, usually they say no earlier than, so, it might actually be later than that, which is kind of funny. That's another thing the aerospace business does that's kind of weird. Normal project management, you worry about the latest possible time you can launch something, and that's usually your goal, is to make that as early as possible. Aerospace it's always the other way. We're not going to do anything any earlier than this or that. That way they're never wrong. Okay, Rocket Lab, we talked about this last time. They're sending a private mission to Venus to look for evidence of former life on Venus on one of their Electron rockets, which is even a small rocket. It just goes to show you can do a lot in a small rocket if you really work it pretty hard. And by the way, that upper stage is doing that. It's from the Electron. It's called Photon. They're using that for lunar missions. There's a couple satellites going to Mars. They're using Photon as well. So Rocket Lab, although they're the second most popular launch, they're still having trouble competing against SpaceX. But the way they've addressed that is they're doing all this other stuff, like having spacecraft that are out going into deep space, even small ones. That's how they're keeping in business. Intuitive Machines will be launching in February. So there's a whole bunch of lunar landers coming along very, very soon. And then the big one's coming along, Amazon's Project Kuiper. That's another one that's been put off kind of forever, but they're finally saying their first operational launch will be this quarter sometime. That'll be on an Atlas V. Their own rockets aren't really ready for that yet. Axiom's doing another private mission, going to the space station. The Dream Chaser space plane. This is, space plane is kind of like a space shuttle kind of a thing where it can land. It's just for cargo, but they were hoping eventually it could be for people. They're targeting May for that now. Now, these Mars satellites, there's a couple of satellites to go up around Mars. That originally was going to be a rideshare on the Psyche mission to a metallic asteroid, getting dropped off along the way. And then that fell through, and they were going to be on the very first Blue Origin test launch, but that missed the launch window. So now they're finally talking about launching something in June. Neutron, this is Rocket Lab's attempt to compete with the Falcon 9, meaning reusable. It is a methane-fueled rocket, so in that sense it's more modern. That's coming up in July. Another lunar lander from Astrobotic. Remember, their first mission failed, not because the lander failed, but actually it was the spacecraft on the way over. They had a valve problem. They had to bring the thing back to Earth. And then Intuitive Machines will be doing another one. Space stations, I mentioned that one briefly. VAST is coming along. In 2025, they claim they're going to launch something. Now, this is not one that has artificial gravity, spinning gravity. But the plan is they'll be able to start assembling that into a larger system. And at some point, they want to have artificial gravity. You view that as, how are you going to live in space? Well, it's not really healthy for people to live in microgravity. So at some point, someone has to test this out. And it's amazing we've gone as far as we have. Nobody really knows how much gravity you need to survive in space. It's just not been tested. We've been doing it on the space station, and what we know is that you can ameliorate some of the problems, but still, it's pretty serious. Okay, now Axiom has a competing space station. They just revised their plans in December. Originally, they were going to just put up a habitation module and rely on the existing power and air and all that kind of stuff, life support from the existing space station. The problem is they were going to go to a port on the space station that now has been reserved for the SpaceX craft that's going to go up and deorbit the thing and destroy it. So NASA said, we need that, so you can't have that anymore. So they revised it, and now what they're going to do is they're going to send something up that's actually a power module, power and life support. They're going to send that first. They'll attach to a different place, just where a normal cargo ship would go. That's in 2027. And then in 2028, they're going to send up the habitat. At that point, they'll decouple from the ISS, and it'll be self-contained right at that point. So actually, this says 2 years earlier than their original plans, they'll have something out there.
There's a third space station project called Orbital Reef, and it's a joint venture of Blue Origin, Sierra Space, Redwire, and others. There hasn't been much news about it lately.
So there's at least 3 projects underway. Now, which ones will actually happen, who knows? But these 2 seem the most likely to get going, except for the fact that Axiom is in financial trouble. We talked about that last time. So there's a whole separate issue there that they may or may not actually make it that far. But assuming they do, they'll do it. What's interesting is Axiom, they actually subcontract out the building of the actual pressure vessel itself. There's an Italian company that's doing that. And they just sent them orders saying, well, okay, you're no longer making the human habitat, now you're making the power module. And it turns out they fitted in pretty much the same space. Okay, then you get much more speculative when you go out a little further here. Starship at some point, as part of its contracting with NASA, they have to do a demo just to show that they can go to the moon and land there. No people involved. And they were talking about doing that in 2025, and that just seems very, very unlikely at this point. But maybe 2026, who knows? It's more of a political question at this point, but what's going to happen with Artemis? Is Artemis, as it exists now, based on SLS, still going to survive? We don't know, but the current plans would be 2026 would be the crew journey around the moon, not landing, just going past it. And then Artemis 3 would be in 2027. I put question marks there because this is all going to be up in the air. Now, in the meantime, SpaceX all on their own wants to send some Starships to Mars, assuming that they're in good enough shape. And again, no people. You look at it this way, how do you do testing on going to Mars? You can only do it every couple of years because the launch windows, planets lining up the right way. So you might as well send a whole bunch of ships, try landing one, and if that doesn't work, change the software and do something different. My guess is that's probably what they would do. They would actually have some incentive to do that if the Starship is far enough along. And it may or may not be, but they've talked about doing that anyway. One of the Indian missions coming up, they're doing lunar sample return missions also. They've got one planned for 2027. And what I should have really included on here is they have a manned space station program going on as well. They've already selected astronauts for it. They've got the plans going. Now, the only one you can probably really count on is China, actually. They've been hitting basically every other year. They have a major milestone. They've got a couple more lunar landers coming. They're getting more and more sophisticated, and they're going to be setting up stuff in 2026 and 2028. And getting ready for a crewed mission in 2030. And they've been on schedule. When they say they're going to do it, they probably will. They could easily beat the U.S.
A question came up on why it's taking so long to get back to the moon.
Well, how many hours do you have?
I'm just wondering, what is the holdup?
So many answers to that. I mean, it has a lot to do with how they're funded. They were basically directed to use old hardware. I mean, pretty much the existing stuff is pretty much based on Space Shuttle. They're using the same engines, literally the same.
Senate launch system.
Yeah, it's called the Senate launch system. So NASA's hands are tied to a certain extent. They weren't really even allowed to develop new technology. But then again, they were kind of willing and complicit in doing this too, because they just saw that as well. That allows us to keep going. It's more of a political question than anything else. The net result has been there's been a lot of money spent and very little actual results because that wasn't the goal. A lot of what that stuff is kind of a jobs program. This is personal opinion here, but it's shared by a lot of people.
Spend the bucks and still not end up with bucks.
You can just say the money was not spent wisely. For instance, you have SLS. Now it appears it costs about $4 billion to do one launch of that. The entire budget for NASA is like $25 billion. So you do a couple launches of SLS, you shoot up a major part of the budget, and that's pretty much a boondoggle. It's gotten obvious that that is not the future direction for how we're going to get to space. If for no other reason than it's way too expensive. You're never going to have a sustainable space program based on space launches that cost $4 billion. It's just not practical.
How about Gateway?
Well, To me, Orion, Gateway, and SLS are all in the same basket of dustbin of history kind of candidates. They were designed for a different era to create jobs and not related to being efficient in going to the moon or anywhere else. But that's more personal opinion. I'm afraid I didn't really answer it, but it comes down to bureaucracy and goals that don't really necessarily match up with the technical aspects very well.
The question came up on the role of SpaceX in the Artemis program.
They're a part of the Artemis program, actually. It's a very complicated scheme where they keep all the existing parts, plus they throw in a Starship. They have a Starship to go up and pick up some astronauts and then drop them down to the moon and then take them back, and then the Orion capsule brings them back to Earth. It's a very elaborate, complicated scheme, mostly because they were directed to try to reuse as much stuff from previous programs as possible. A lot of people would say that. Anyway, I guess that's it.
I guess that was the discussion right there.
Yeah, I mean, yeah. Okay. Okay.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.